Good afternoon, and welcome to PV Magazine Week Europe. I'm Matthew Linus, one of the editors on PV Magazine's global team, and today we're going to talk about quality and bankability. In this session, we'll be joined by expert guests who bring experience from across the solar industry. And my goal for today's event is for everyone to leave having learned something new, hopefully something that supports your work in the future. So let me set out the agenda and then we can dive straight in. So first up, we're going to be joined by Intertek CEA to discuss some of the most common quality issues affecting PV plants today. We'll have a presentation and some questions with Director of Engineering Services, Jörg Althaus, who brings case studies from the field for us. More on that soon. From there, we'll move on to discuss electronic balance of systems with Shoals Technologies. Josep Tienda, Vice President of International Sales, has prepared a presentation which I'm sure is going to touch on issues like quality, performance, all key pillars to project bankability. And getting procurement right is, of course, critical. So we'll be joined by Andrea Viaro from Global Head, of EPC at Stoibri. He will be with us to present some project bankability field data on technical failures, the cost per kilowatt hour per year lost due to those failures, how to avoid those risks, and more. And then at that point, we'll be joined by a trio of CEOs. We've got David Penalva from Heliovolta, Tim Humpage from British Solar Renewables, and Govinda Upadhyay from Smart Helio, who, along with Jörg, Joseph, and Andrea, will here basically to discuss all of the stuff that we've talked about above and more, really ensuring quality and bankability in European solar. So that's the agenda for today. But first, we should just dive straight in by welcoming Jörg Althaus from Intertek CEA. We'll start by saying, he's the Director of Engineering Services and Quality Assurance. He is part of the Intertek CEA team, and Intertek CEA are, of course, gold sponsors for PV Magazine Week Europe. Now, I believe Jörg is going to share some insights on some of the most common quality issues affecting PV plants today, and we will, of course, discuss some of the ways to mitigate these risks. First of all, Jörg, thanks for joining us. Are you there?
I'm there, if you can hear me. Thank you so much for having me and giving me the pleasure to talk to your esteemed guests.
Listen, thank you again for joining. Rather than me quizzing you right now, I'll get out of your way if you would like to present what you guys have found, and then we can maybe discuss soon.
Sure, thank you. I'll dive right in. Just first a few words on, if you don't know, Clean Energy Associates, that some of you may know us as, has recently rebranded as Intertek CEA, part of the global Intertek family, with more than 44,000 people globally. CEA acts as the third party within this organization in 5 business units, covering supply chain management, where we help buyers to make the right contracts with suppliers, do quality assurance in the factories, and then also bring the quality to the field through our engineering service team. Market intelligence is another business unit where we help clients to learn what is the technology trends and what is the price learning curves for all the equipment, storage, modules and inverters and the like. And finally, ESG traceability has kept us busy over the last few years. Enough about the snapshot of the company, and I would like to start a bit with saying where is the solar industry currently at. And if we look at the graph on the right, we see what is the suppliers' announcements for manufacturing capacity on module side, and then what has really been is expected to really come to life. First of all, you see more is announced than is being actually done. But on the other hand, we foresee that the global installations are actually slowing down a little bit over the next years with policy changes and so on. But in general, you see on the blue line that the actual installation range for 2025 is below the capacity, and that will maintain for a couple of years. And therefore, even the Chinese government is holding discussions for a while now to slow down the expansion speed and the capacity. There is talks about EU funding for local manufacturing, but we have yet to see real materialization of the same. On the other hand, we've seen rapid ramp up on US facilities, Middle East and Africa. So in general, there is a race still for capacity expansion, but the market is not taking up that full capacity. So we are maneuvering in an overcapacity market. What does that mean? In an oversupply market, prices usually and the margins are shrinking, which puts suppliers under pressure to save cost. As a first reaction, people start putting cost pressure on materials from their suppliers, processes, inspections, and testing. So as a result, quality usually suffers first. And also we see, modules are seen as a commodity, and many of the buyers buy cheap rather than best in class. And suppliers follow that trend, offering a cheaper product rather than working innovations on the high-end, high-margin products. And therefore, focus currently is on cost saving. And with that, I brought a couple of case studies that may be a result of such cost savings. A lot in the industry we've heard in the last year or two on rear surface glass breakage of PV modules, with really a global trend that we've seen. And where do we come from is typically, up until recently, module manufacturers were building glass polymeric backsheet sandwiches with 3.2 millimeter fully tempered glass. Nowadays moved to 1.8 to 2 millimeter rear and front glass, partially tempered. At the same time, the frame has changed its design and has become also a little bit weaker, and the module has become bigger. That on the other side meant that the racking manufacturers had to change design and adapt and change the increase of the rail size, hole pitches in the design, and gasket location. Lift up the whole system a bit from the ground to have enough clearance, and look at the static calculations. However, what we see in the field and in testing is that in some combinations there does not seem to be enough safety margins. And that I just present this for now. We will discuss later. But as a result, we see, and I heard from many of our market companions that this is a global issue at the moment. Some modules facing glass breakage and confirmed in lab testing. Second case I brought that I wanted to discuss is soldering issues inside junction boxes. And here again, a little bit of a look in the past. Some of the viewers who may know me and know that I've been in the solar industry for 25 years. So I have seen the early iterations of junction boxes here on the left, very simple designs. Now, of course, nowadays, very different designs. But what has changed on the module is that the current has increased a lot. And usually nowadays we see modules with 3 junction boxes, each with one diode, very small, very compact, high IP protection, durability, much better materials than in the past. But at the same time, the current is very high, and the weak point is still the soldering. Some manufacturers are moving to welding rather than soldering. But again, the result of weak soldering points are multiple. First of all, a bad solder connection means a higher series resistance and hence an increased risk for heat dissipation, which can finally lead to a thermal event or fire. And manufacturers use AI-powered cameras to detect issues, but we still see those failures in the field. And another failure that you don't see visibly on the junction box is if the diode is not connected correctly. That you see here 2 schematics. On the left, you see if the string connection or one solder point from the string to the cell from the diode is disconnected, you just lose, or you lose 1/3 of the power, but you can detect it very easily. The other more dangerous part is if the junction box, the electric circuitry, the cell is still connected, but the diode is not. Then the function of the diode is lacking, and in a shading situation, which you see on the graph in the right, you will see that the full power of that string needs to be dissipated in that one shaded cell, which will lead, because we have such high current these days, to potential thermal event in the cell circuitry. This is not so easy to detect. We call it the lost bypass diode, but we can come to that also later in the discussion. And that was basically supposed to be my starting point for discussion. So not wanting to shock anybody, but just see where we are navigating at the moment.
I want to scare the viewers, but obviously there are some significant quality issues that we are going to talk about today. The sort of junction box stuff, I think I really would like to pick up on the panel, because we've got a lot of people there that have experience with detecting faults and so on. I don't want to let you go without just a brief word on glass breakage, though. You know, Intertek CEA has to deal with this issue, and it has to deal with it in a market of oversupply and the kind of dynamic you've just described. So have you adapted your recommendations or your suggestions to clients in the way that you approach this to just try and mitigate that risk in any way?
Sure. I mean, there's multiple layers to that. One thing is I want to make clear that the glass breakage may have multiple reasons. It could be a material issue, it could be a design issue, it could be a combination of the module together with the mounting structure. So first thing needs to be said right is make sure there's sufficient incoming goods control on the material, meaning the glass at the manufacturing site. So that's something where we changed our process and our recommendation to our clients, what should be in the contracts and also in the quality control in the factories, to make sure that the material part is at least covered. And then, of course, put a focus on how the framing is done. And when I mean the material check, also check in the factories about the edge grinding, the holes, and all of that. But also the framing is crucial. If there are any impurities in the frame parts that can make the glasses break. But then one important point is there that when testing is done for PV modules, it's typically done on a uniform load according to IEC standards, while in reality, the racking manufacturers, they will test their system in a wind tunnel, which provides a non-uniform load. The combination of both is hardly tested. Usually one side tests this, the other side tests that. And so our recommendation is to do field representative testing of the actual module mounting method with the representative parts from the mounting part to represent the real loads seen in the field to avoid any weakness.
Right. Okay, that's really interesting, Jörg. It sounds like we need to do a bit of joining the dots more between sort of racking and module testing, and I'm sure we could talk about that for much longer. I'll ask you to step away for a moment and happily welcome you back to the panel later. But we're going to move on now to another key quality bankability subject, which is, of course, electronic balance of systems. Now, we're joined today by Josep Tienda, Vice President of International Sales at Shoals Technologies. Josep, first of all, thank you very much for joining us. I hope you're here with us today. I believe we should be there now. Are you there, Josep?
Hi everyone. Thanks for having me. It's a pleasure to be here today.
You know far more about the Shoals approach to prefabricated EBOS than I do. So what I'm going to do, similar with Jörg, let you go ahead right now, explain to us, your approach, and then we'll pick up with a couple of questions on that as well.
Fantastic. So we will discuss today who is Shoals and why we are a leading player in the balance of systems market. What is actually electrical balance of systems? Typical designs that we see, the challenges that we find in the projects nowadays, and how prefabricated industrial EBOS can ensure quality, longevity, and bankability for installations. So, Shoals Technologies is a global manufacturer of electrical balance of systems. Electrical balance of systems is anything which is in between a solar module and the inverter. just ranging from junction boxes, harnesses, inline fuses, combiner boxes, and even wire management. We were initially founded as a tier one automotive supplier, which set up a lot of things that we're currently seeing in our current manufacturing capacity and quality procedures that we have in place. We pivoted to solar in 2002, sorry, and we went public in 2021, which was an excellent event for Shoals, because that was the first and biggest IPO in the energy field. We recently won in 2024 the PV Magazine EBOS award. We did that as well for 1,500 volts, and we did that as well for 1,000. So we've been there since the beginning. We actually invented the concept of harness and fuses, and we just were awarded another award on our best recombiner design that we've done. If we look at what we've done and where we operate, we have installed more than 82 gigawatts worldwide, and we have currently up to 67 patents. Those patents are a trademark of all our IP and efforts we put into make solar more affordable and more competitive worldwide. We are localized in different locations. You can see we have manufacturing capabilities in North America, Europe, and Asia Pac, and we are compliant to all the different standards across the world. So if you want to see what graphically where our products go, you can see in this graph in this slide the different components that we offer. You can from the top right corner you can see junction boxes, BLA, which is an above ground bus trunk system that allows you to combine different strings without the use of combiner boxes. We integrate the connectors, obviously, and fuses, combiner boxes, and then after the inverter. Okay, so if we, what we see is currently in the solar market, most of the solar installations don't use industrial EBOS solutions. Most of them done on a DIY method, so that means they are assembled at the site. Here it shows what we have. We have different architectures that will allow our customers to improve their installation time, but having less workers doing that installation, improving the quality of the installation by reducing totally any potential issues with the electrical installation. And depending what inverter architecture we have, Shoals can provide different solutions. If it's a regular shape, we could just go with the most advanced installation, which is a BLA. As I said before, is an above ground DC trunk bus solution that allows you to minimize and reduce the use of components on the site. So you are integrating everything into the electrical architecture, making the system less complex. Then if the site is irregular, like we see in some geographies in Europe, for example, you can have different approaches that would allow you to achieve what is the best for that project, ensuring that the customer is going to be, in this case, the EPC is going to be using less people, will be able to impact the way how they're going to be building that project in a very different way, because you're not linear anymore. You can just basically introduce different parts of the ecosystem in different times, allowing you not to have a fixed schedule. And then, if we have a system where, for example, there's a requirement just to go trenches, we could just use a harness and high current combiner box approach. If for some requirements, some customers want to have just single connections, we can actually do that as well with individual home runs and combiner boxes. We have introduced a new product called Super Jumper that will allow you to actually reduce the material use in terms of copper and just introduce aluminum the same way we do with the BLA. And that's going to be giving the customer different options to be able to build that solar project. If the customer is opting for a multi MPPT string inverter, we can do that as well. But that's from what we see at shows, that's the less competitive solution, because in most cases it's making customers to actually do that installation manually at the site, and shows can do it as well industrialized, but it's the less competitive solution you can find in the market right now. So why EBOS is critical for solar and storage projects? What we see in terms of safety is that when you are doing all the wiring and the installation at the site, you are basically opening yourself to main failures on, as we can see, as we'll see in the panel today, on connectors, hotspots. Depending what solution you're using, you're going to be having installation problems where you're going to get external influence in the harness, and you're going to have electrical issues and arc faults. The efficiency is having a solution like shows will just minimize totally the power loss that you have in the system, and you have the best energy yield you can get out there. On the reliability and longevity front, our solutions are designed to actually last the 35 year of the project, so you will not have to reinvest, you will not have to worry about performance going forward, and your project will be bulletproof. When it comes to scalability, our solutions are very modular and allow you to actually install things a lot faster, reducing the typical works you find on a DIY installation, and that will allow you to improve the time of the installation, as well as on the operation and maintenance will reduce the points to revise, and will give you a much easier and cost-effective structure. As well in cost control, that goes as well with determination. Everything is terminated, as I said before in the previous point, and you will not have to worry about potential paybacks and reinvestments. And then last but not least, sustainability. Our solutions are designed to minimize, optimize the material used, and in the end, it has a lower impact on the environmental point of the equation. So now we're going to see a short video that is basically very So as you can see, this video shows the different conditions you will find in a solar installation, how our BLA copes with them all. Our process, our internal process in mold and out mold allows you to have this type of solution that is going to be working for the life of the project without having to invest. So traditional systems have two main challenges. The first challenge is that when you see a DIY installation, is that you have loads of wire being used. So typically, most designs, you see them with multiple wire runs for the same distances. So you're just covering that twice in most of the cases. You have different connection points in the middle. And the second challenge is that field work in the end is going to, as I said before, is going to have a lot of quality and yield issues. You can control that everything is going to be done in the same way you're going to be doing in a factory control environment like we do at shows. All the solutions in this case, when you find a DIY installation, is with connectors crimped in at the site. And you can, every time you will do it differently. And especially that everything that you do is going to be subject to a person doing that. And, we all know that we can make errors, and these errors compound in a project, in a solar project. There are also, many risks and potential rework that will need to be done. And as such, we propose different solutions to actually combine that. If you look at traditional home brand architecture, you have like 8 compartments. If you start from the right, you have like 24 to 30 panels per string, up to 24 strings per combiner, and then up to 8 combiners per inverter. So that's almost 2,200 connections per each inverter, and that every single one needs to be done manually. So imagine how many errors you're going to be finding in these sites. So what we do is, with our solutions, as I mentioned in the slide I was showing the architectures, our objective is to reduce the number of critical points of failure, and by doing so, when you just bring that installation into a factory control environment using an automatic process and our in-mold and out-mold technology, you are basically just allowing your installation to, on the CapEx side, as I said before, reduce a lot of potential time constraints, but also you actually reducing the number of components you're going to be using, because our architectures, what they do is they integrate the components in the wire piece. We've seen like in the harnesses where we can have different harnesses with inline fuses in there. So with crystalline modules, we can have up to 2 strings per harness, and we characterize and we put that inline fuse in that harness without having to work the combiner box. So what we're doing is we're reducing what's inside of the enclosed products, and we bringing that into the harness and bus architectures. So when you do that, you're just reducing all the different issues you're going to be finding in a combiner box. And in the long term, at the same time, you're going to be, you're going to have less things to inspect. And since the quality of our products, the components that we use are the best out there, you're putting yourself in a position that you will not have to invest. So what is it that we see when you see field work? Like I said, the process, I don't know if everyone has the process in their minds, but the process is this one. And as I said before, 2,200 times repeating this constantly. That's basically open a major window for potential issues in the field that we're seeing nowadays in many revamping requests and repowering requests that we see from customers. So when you move all the fabrication to the factory, what you are, as I said, is like using the fully automatic factory machines that we have that allows you to protect anything that you do. When we do a harness, when we put combining 2 strings into one harness, we use again in that particular joint, we use as well our in-mold and over-mold. Our in-mold will seal completely chemically that point, and then we'll have an over-mold that will just cover it and make that connection bulletproof for the life of the project. Our machinery has been designed and built by us, so it's our own IP. And in the end, what this translates is that you're not having any errors. All our systems are tested. We'll see in another slide going forward, but you are ensuring that in these conditions, nothing is going to be affected by any type of human error, and everything has been tested before it goes out to a project. One of the things that we're seeing nowadays in the solar installations is that we are starting to see companies trying to offer our DC bus approach with invasive solutions. This slide shows you a comparison between our above ground DC bus trunk solution, non-invasive. So what we do is we have our transition. The BLA is a transition from copper to aluminum, and we do that because is the most competitive solution. You know, you have three different ways of reducing the cost of the solar installation. One is by the integration in the harness side. The other one is using a DC bus trunk solution that combines and transits from copper to aluminum, and the third one doing it above ground. So in this case, when we compare this with an IPC, our solutions are very different and much more reliable and resistant to the life of the project, because nothing is done on the actual job site. The EPCs are solutions that you are building as you go. You actually buy the cable and break the cable and put a connector, and that's done manually each time, and nothing has been tested. So everything is potentially and is very often subject to external contamination, and provides a lot of issues on the field. Our solutions are designed and manufactured just to ensure that the inverter is protected and you don't have any issues in terms of yield and therefore downtime. So if we look at the quality testing, we have a very exhaustive quality process in place. As you can see, each one is one product and has a different process. But the process that shows not only starts with our products and the different tests that we do our products, it starts as well with the different suppliers that we use. We only use tier 1 suppliers, and we have a different number of potential providers, but these providers need to actually fulfill a very demanding quality requirements from shows. So as I mentioned before, our design life is just for the long-term performance. We're not looking for something which is cheap and needs to be then reinvested. Our solutions have been tested to prove that we can just go far beyond the market requirements on UV exposure, high temperature, and water ingress. Our solution IP68. That means that you can just immerse them in water, and thanks to our high testing capabilities, we just go far beyond, and it's even our BLA can be even used for any type of solution that needs to stay in the water. So if you want to reduce the safety risk and improve the cost effectiveness of solar, you need to make sure that you integrate the EBOS at the beginning. You get shows involved in as soon as you start thinking about your potential block, and our engineers will help you to optimize that design and find the best architecture for that project to impact both the construction time, but also the LCOE, improving the LCOE of the project. We can always suggest you and advocate for not using invasive solutions anything which is requires to break or do a connection on at the site is a potential serious issue. We see most of the issues that we see nowadays in a solar installation come from the DC side, and most of them are due to the connections and the connections that have been used. And always try to actually go for a partner that offers something which is balancing capex and opex. It's not only capex, but it's also what are you buying, how long that solution is going to last for. Thank you very much.
Thank you very much, Josep. That was obviously a big tour there of Shows Technologies and all the kind of different solutions you have there for balance of system. I have a whole bunch of questions I would like to ask you. I'm only going to be able to do one because we have one more presentation, and then we'll get back to you on the panel. Just very briefly, you mentioned there, that you've got these different kind of local manufacturing partners and so on, or local testing and manufacturing. How are you ensuring that supply chain is of the quality that you require, in all the different key markets, whether that's Europe, the US, or other continental markets?
Well, the quality for the supply chain is very serious for us, because in the end is a part of the offer that we do, that is going to be building our products. So we need to ensure that we are using the best partners. As you could see in one of the slides, we just basically break the different tests that we do in our factories. There's a specific test for solutions that are for the components that we get from our vendors, to ensure that they meet our requirements for the different products that we do. We can replicate that in all our factories across the globe. It doesn't matter where you buy from, in what factory. Everything has been done in the same way. We have the same process, and we want to make sure that whatever we include in our ecosystem, it has the best quality out there.
All right, Josep, thank you very much. I think I might have counted 19 quality tests on that slide, but I'll let people check the handout as well, because don't trust my counting. And so that's Josep there from Shows Technologies, Platinum partner with PV Magazine Week Europe. So thank you very much for joining. But now, if we can move on to Stäubli, our gold sponsor here, Andrea Viaro. I believe you are on the line with us today as well. Thank you for joining, Andrea.
Hello, everyone, and thank you, Matthew. Really happy to join also this edition of the PV Magazine Week in Europe.
Well, listen, Andrea, I don't want to keep you from it. I know you've got a whole bunch you can present to us now on kind of the decisions that can be made on connector purchasing and the sort of long-term effects of that. So how about I let you make that case, and then we come back and talk about it.
Absolutely. Thank you, Matthew. And I just want to give you and the audience an impression about why we identify connectors and EBOS, electrical balance of the system in general, as a potential source of risks for a PV system, also related to what Joseph was highlighting just now, and also Jörg in his presentation. We saw how critical is the importance of having high quality EBOS components, which can withstand the entire life cycle of the PV system, and how even electrical connections on junction boxes, for instance, are really a delicate point when it comes to potential failures or problems in the PV fields. And why is that? Most of the times it's because of still a little lack of knowledge or awareness or underestimation of how important are connectors and DC cabling in general for a PV system, which is, as a matter of fact, as weak as the weakest part of the chain, and clearly this creates a hidden risk, in the sense that underestimating the importance of even the small components can lead to failures which have impact on the rest of the installation in terms of components, potential damages, performance losses, and other liabilities related to that. And that's highlighted also in many studies available in the industries. Now highlighting on these slides only one of them, which is the PV bankability study that was developed in the 2020 with the European Commission support, which highlights and quantify, even directly financially speaking, the impact of any type of failure that can be detected in a PV system. On this graph, we see the top 20 list, and we see immediately how at the bottom of the chart are mentioned many of the potential failures which happen related to connectors or DC cabling in general, which have, in fact, the highest impact in terms of financial loss per kilowatt hour in a PV installation. And that's exactly for the fact that underestimating these factors or the importance and the potential impact of connections and EBOS failures lead to underestimating the consequences of that, exposing ultimately the plant to additional risks, which are not related only to the failure of the connector or the EBOS components themselves, but related to potential damages to other components, as we saw in the first slides with the picture of the burned modules. So there is clearly a potential direct impact on the overall hardware of the PV plants, modules, inverters, just to mention one. And even going further, exposing the plant and the owner or the parties involved into the design, construction, and maintenance of the plant to further liabilities in terms of warranty or even ultimately legal liabilities, which are most of the cases not quantified initially, not expected, not wanted in any possible way. Going through a couple of quick case studies that we saw in real life. So just to confirm that also the studies are not only theoretical numbers and evaluations, but really, unfortunately, in some cases, concrete cases that translate into real failures. And in this case is a case where cross connection was detected in the field, the plant in the UK. And just after a few months of construction, was detected already the first failures. The interesting fact of this case is the fact that it's very visible, not only connectors damages were identified, but also connectors to the other components, just to confirm what I was mentioning just earlier. And also the evolution of the failures and the number of failures increasing over time. So just after a few months later was conducted, for instance, in this case, a second inspection, and the number of failures were increasing by a factor of 4. So it was quite clear how, when talking about connection problems or electrical failures, is a matter of time that when there is a hidden risk, a hidden problem in the system, this is sooner than later leading to damages potentially, and with increasing trend. So in this case, it's a matter of time when connectors will start to fail, in this case because of a cross connection, so connectors which are not supposed to be mated together, and number of failures increasing over time. So highlighting how the evolution of that is not evolving. The situation is evolving over time because of the stressed electrical stress that the connectors are exposed to. The second case is related to probably the main, or for sure one of the main source of damages and failures for talking about PV connectors, which is the field assembly. And that's also for the reason that lack of knowledge, unfortunately, or probably unawareness is still present in many cases, in the sense that not always connectors are handled or installed according to the manufacturer guidelines, or using the correct tools or the right procedures to do that. In this case, this led to a thermal event, how defined in this slide, which is a fancy and a polite way to say that a fire happened on this rooftop installation, unfortunately. And this led not only to, clearly, as you can imagine, troubles in terms of damages to the PV plant, and then additional costs for reconstruction and rebuilding the plant, replacing all the components, but also in terms of losses for the electricity that the company, which was owning the plant on the rooftop, was having because of not expected purchase of electricity that were not planned not planned to be done, and then this led to an additional 100,000 euro per month bill to the company just for the electricity that they had to get from the grid instead of using the self-consumption from the PV plant. So, as a conclusion, the hidden risk that we see related to connectors and EBOS components in general can lead to liabilities and a deferred capex, as we many times define it, because in the long run, electrical connections or EBOS components can, when not chosen and designed for the long-time reliability, can really lead to failures and damages to the PV plants. So an initial small saving potentially on low-quality components or not optimal design or construction can lead to significant damages and losses over time, over the lifetime of the PV plant. So that's why it's crucial and paramount to have the right knowledge, understanding of the potential risk that is related to certain choices, and therefore to make the right choice in the beginning, starting from the design and construction and down to the operation, maintenance, and decommissioning in the end of the PV plant. Thank you very much, and back to you, Matthew.
Thank you very much, Andrea. That's Andrea Viaro there from Stoibli. Andrea, I'm keen to get to the panel where you can all talk together. We've got too many talented people on this call to just listen to me. But what I would love to know, first of all, just on the back of the things you've uncovered there, these kind of failure mode evaluations, the effect analysis, is this something that investors, PV investors, financiers, do you find them switching on to it? Are people getting a bit more awareness about the kind of issues that you're raising here, that these common failure modes that are, perhaps coming from somewhere that's not a huge increase in investment, but then later down the line, as you highlighted in some of those examples, 100K more, big costs?
Right. Yeah, Matthew, that's correct. And that's why also most part of our time is really dedicated to this education and awareness that we want to really reach with the operators and the asset owners, the developers, the EPCs, everyone involved into the value chain, because the risk is really to significantly overlook these situations, not to consider the real potential impact, also financially speaking, related to that. And unfortunately, still today, there is, let me say, still a lot of work to do in that direction, especially for what I mentioned earlier, because of the small component that connectors represent are many times disregarded in the value chain. And while we pay a lot of attention probably to major components like modules, inverters, there is still a lot of understanding and knowledge missing in many cases from the developers and operators about the risk that they take for the investments that they make in this case. So that's why paramount is really the education and the knowledge sharing that we are promoting, and trainings also for the installers, EPCs, to make sure that the right choices are made and the connectors are used and installed in the best possible way to guarantee reliability, long-term reliability, safety and performance of the PV plant.
All right. Thank you very much, Andrea. Well, we'll be back to talk about this some more, I'm sure, soon. But I would like to move us on to almost the second half section of this quality bankability session, which is the panel discussion. And the best thing about this kind of PV Magazine Week Europe is that we can bring together so many talented experts to discuss key issues that are facing us. So, of course, we have David Penalva from SolarGrid and Heliovolta. We have Govinda Upadhyay that's joining us from Smart Helio, and we have Tim Humpage from British Solar Renewables, along with the presenters that you have already seen today. But first of all, I would like to welcome David from CEO and co-founder of SolarGrid by Heliovolta. Now, David, are you here with us now?
Yeah. Hi, everyone.
Thanks very much for joining us. I'd like to start with you, first of all. You've analysed more than 100,000 PV system health data points at solar plants, I believe. What have you uncovered in terms of quality? What's going on with EPCs?
Well, first of all, Matt, thank you for having me. As you know, I'm very passionate about quality. I'm excited to be part of the panel today to discuss this topic. To lay out the ground here, just introducing myself, I'm the CEO, co-founder of Heliovolta, which is a technical advisory company specialized in quality assurance and quality control at the project level, and also co-founder and CEO of our sister company, fieldwork management software application called SolarGrade, which allows companies to digitize fieldwork and produce data-driven decisions. As the kind of laying out the ground here for the discussion, I'm gonna bring up some interesting data points based on our recently published 2025 PV Health Report, which is the largest independent EPC quality report publicly available out there. And we collected a lot of data from thousands of projects in the US. The conclusions are very applicable to the European market. And as you mentioned, we have 300,000 data quality points and evaluated more than 120 EPCs and their subcontractors. So the main three takeaways out of that study was, number one, quality varies significantly among EPCs, up to 3 orders of magnitude. This is going from almost 1,000 times from the worst performer EPC to the highest performer EPC in terms of issues per megawatt. The second takeaway is that the EPC company size, years of experience, or location doesn't really matter. It's more about the DNA of the company. You can find some small EPCs that have great quality because they have good processes, they have good documentation, they have their teams properly trained, and that translates, throughout the company, while some other larger companies might not. So it really, there's no rhyme or rhythm with regards to quality on company size, years of experience, and so on. And the third takeaway is that 67% of these EPCs that we look at did not meet our Heliovolta quality standards. And those quality standards are based on the number of issues per megawatt, with not allowing, so basically 0 critical issues per megawatt are allowed, less than 2.5 major issues per megawatt, and less than 50 minor and negligible issues per megawatt. We published the whole risk severity metrics and kind of socialized it with the industry in our previous PV Health report from 2024. And, it gets into a little more color there if you want to know where these metrics come from. But going back to, we had a couple of, panelists here presenting where are most of the issues concentrated out of our experience. They are in the DC distribution field. So anywhere from the solar model all the way to the inverter. And that goes from, solar models, connectors, MLPs, module level power electronic devices, wire management, and anything related to wiring, connectors associated to home runs, grounding, terminations, and so on. That's the highest concentration. Probably 80% of the issues with regards to quality are concentrated on the DC distribution field. Why this matters? I mean, as you guys know, quality impacts performance, number one, ongoing operations maintenance cost, and third, safety and reliability. And not to mention the F word. A couple of people already dropped the F word, with regards to fires. So it is a big deal. So quality has a huge impact on how these systems operate. And just to finalize my ramble here, there are good news on things that you can do about it. Like, based on our experience, there are 3 specific action items that you can take that will help you improve the quality in your projects. Number one is that you have to be able to measure it. If you don't measure quality, you're lost. If you're in the industry is getting mature enough that if you're a serious player as an EPC and you don't measure quality, you're in big trouble. You're completely blind to what's going on your systems. And this is extremely important. So first, measure it. Second of all, is track it. Like, okay, what are you going to do about it? Now, try to resolve, create actionables as soon as possible, remediation campaigns, or tackle the issues from the beginning, and address them as soon as possible. Keep records and documentation on how the remediation was done. And then the third one would be oversee it. So if you don't have either, in our experience, like a third party overseeing the quality is the best ROI that you can have as an asset owner or developer for your projects. That allows to keep accountable the EPCs and their subcontractors, and verification that the work has been coming through quality. When we track a few EPCs and their subcontractors over 3 years, the period of 3 years overseeing them, we saw a reduction in issues per megawatt of up to 60% year over year, which is a huge amount. And this tells you that you have to give them the feedback loop so they can train their teams, they can address their problems, improve their documentation and process and procedures, and get better over time. And they do get better over time. But there's a little bit of effort that we have to do as an industry. And again, everything that I just discussed, you can download our PV Health report in our website, heliovota.com.
Yeah, listen, David, it's certainly not rambling. I believe you said that, but no, I think that comes through clear to most people in this panel, if not all, with rough experience of the kind of things that you've discussed there. You have a field operations platform. The message that's coming through to me, at least, is that this DC distribution is what needs to be made bulletproof, right? If I'm looking for backing, if I'm looking for quality, this is the area where I need to make sure I have processes in place and where I have to ensure that people are trained up in over a period of years. Is that a fairly accurate representation of where we're at the moment, do you think?
Yeah, and this is a constant process. It's not a one-off. As you can imagine, people come and go. They go from one company to another one. There's new process, there's new technology. So there's a constant need for training on updating process and procedures as we go. So I see this as a never-ending task that has to happen. It has to be part of your DNA as a company.
Okay, perfect. Well, listen, we might pick back up on that soon, but I would really like to bring in Tim Humpage from British Solar Renewables. He's the CEO. For those in different markets who might not know the business, British Solar Renewables is an IPP. It's also got an integrated EPC business. So it's quite an interesting combo there. I'm sure Tim is about to tell us a bit more about how that works. I believe you've developed more than 900 megawatts of solar projects, and you did make some headlines earlier in the year with a really big financial close deal in excess of £300 million, I believe. So knows a thing or two about bankability and quality. Tim, you have heard some of the things that David has just mentioned there. I'm wondering how much that resonates with you, and you can maybe tell me how you think your approach of having this integrated EPC relates to quality as well. Having it all in-house as a developer, how you pay attention to it, and if you're basically applying the same kind of processes that David has raised there.
I think everything that David said applies to us. It was actually really interesting listening to how you be a good EPC. I think that the sort of two key words that I wrote down whilst David was talking was culture and DNA. I think that as British Solar Renewables, we have quite an interesting DNA. So 15 years, we have been fully vertically integrated IPP. Slightly upgraded numbers for you, Matthew. So that's 92 power plants we've done, which is just over 1.5 gigawatts over those 15 years. So we started just ahead of the Solar Coaster in the UK. We still O&M the first 2 power plants that we built in 2010. So that means that we've got 15 years worth of data information. Rolling that back through our company has been vital to what we do. But the reason that we have an in-house EPC is to control everything that David talked about. The reality is that, yes, we make a bit of profit as an EPC, but what is more important is controlling those risk levers in terms of quality, in terms of design, in terms of cost, in terms of speed of deployment, and in terms of safety. So we can actually deliver for ourselves in a way in a way that makes sense. We're also an in-house O&M as well, and asset manager, and obviously yield co. So when David talks about investors, we are our own investor. So all of the thought processes that he's having on behalf of investors, we do that all in-house, and it sits with us. But what we've learned over 15 years is actually to do solar and battery and wind, it's about doing the same things repeatedly well, and partnering with people, whether that's from a supply chain point of view, whether that's from a subcontractor point of view. We have the same crew of LV subcontractors that we've had since 2012 across our UK build sites, and you build those relationships. They understand what quality looks like. If I think about, I spoke to our O&M guys before I came on the call today, just to ask about fault levels across our sites. For this year, we're looking at having 99.86% availability across our entire O&M portfolio as a business. In terms of what we have delivered over the last 3 years in the UK, we have not had a single connector fault. What we've looked at with the rest of the team on this call this morning, that we recognize an awful lot of those faults. If you go back through the history of solar, particularly during the solar coaster here, when we were deploying, and the UK is not a brilliant place to go building because it's permanently muddy. It only ever rains, as you can see behind me out of the window. I often wonder why I'm in the solar business in the UK when it looks as dark as that. So we've learned the hard way, but actually taking those lessons into your DNA, into your culture, and building on them, I think is entirely why we are where we are today. Last bit, probably for me, not wanting to feel that I'm waffling on as well, it's to do with structure and where's important. Quite early on in our journey, we removed our commissioning team from our EPC business, and we put it in our O&M business. What that did to our same commissioning team, what that did for us was it gave us consistency across every site. At the moment in the UK, we are currently in build across 8 projects that range from 25 meg to 150 meg. So you've got a lot of autonomous teams out there in the field, all going flat out. And actually, unless you've got somebody that is looking across all of that, comes back to David's third party point. So we've effectively replicated that in-house. How do we have somebody that is looking at all of our plants and knows that we're getting that consistency across everything that we're building? Plus it ties it in with our O&M. We're going to own those plants for the next 40, 60 years. We're going to be the O&M on those projects. So therefore tying our IAC and FAC process, our commissioning process to get us to TOC, in with starting that 40-year journey at that point has been really important. And then last thing is engineering. We have centralized our engineering. So actually our engineering team looks at everything from development and putting in planning permission all the way through to O&M and yield co through EPC. So everything that we learn at either end of the business gets tied in as we go through, which I think feeds into everything that the rest of the panel has been saying.
Yeah, absolutely. And you mentioned there, obviously, relationship seems to be incredibly important, not just to your business, but to quality in general, right? Reliable suppliers that you've known for a long time. And then I guess also your reputation as a business is going to help you do business down the line. I'm wondering, Tim, if, we heard it very much at the start of the session from Jörg that some quality issues emerging, and of course they offer third-party auditing services. You have these great suppliers that you've worked with, but does the way that you assess and work with those have to change? When you're on the phone to your EPC director, do you get new headaches? What in 2025 is your approach to making sure that those suppliers are still on top, everything is still quality, and the things that you're taking onto site are as good as they were 10 years ago, 5 years ago, perhaps when as you say, the solar coaster was at different peaks and troughs along the way?
So we start thinking about quality and supplier quality quite early on. You've talked about the $450 million debt raise, the senior debt raise that we did beginning of this year. Obviously, the bankability on to get that level of money across 4 banks requires you to start thinking about what your procurement looks like and the quality in your procurement before you hit financial close. We're able to do that. It helps having an in-house EPC, because effectively you can appoint your EPC before you hit financial close if you are your own EPC. So it ties up a lot of those chicken and egg issues that lots of other people have. But it means that we're thinking about quality way ahead of time. From a module point of view, we do in-factory assessments, we do in-factory testing with our OEMs in China. We do that from a bill of materials point of view very heavily. Obviously, we're talking about quality a lot on this call, but from a bankability point of view, one of our biggest challenge in terms of supply chains is the ethical side and the governance side. And so we've put a lot of effort into that. We've worked with Solar Europe and Solar UK in their task force. We were actually ahead of them in implementing our own governance systems around our own supply chains. So we're already in the factories. Because we're our own O&M, when we do testing from an EPC O&M point of view, we don't module test when we're doing the EPC. We wait until we've fitted everything, and then we do drone thermography across every one of our sites every 12 months. If we find an issue, we will then do on-site testing and we know CEA very well in terms of those processes. And so have that escalation, and that again, we're slightly different to others because of the fact that we're a joined up Yieldco and O&M. It allows us we don't have to get everything done by TOC. We can take a slightly different view on that. So that's how we work.
Excellent. Thanks, Tim. And I'm sure Jörg would be able to tell us as well that CEA does. I'm aware quite a lot now on this ESG thing. But before we get to that, I feel like I have to bring in Govinda at this point from Smart Helio, because we're talking about procurement and fault finding. You're using AI algorithms, as I understand it, to analyze data points and trying to identify faults before they happen. So how does that work? And let's be honest, you're going to put all of us out of a job.
Thanks, Matthew. No, it's lovely to be here, and especially with all the folks here talking about the same mission, that let's keep the solar plants healthy and keep it as long as possible so we can extract maximum clean energy from them. At Smart Helio, we are based out of Switzerland. We also work in US and India. We have offices there. Right now, we are globally present. We also call ourselves as a doctors of solar plant, and I think that's one thing people will remember now. Doctors of solar plant. It's exactly same why we go to doctor. Prevention is better than cure. We are seeing a lot that if we can detect very small fluctuation on the DC side, as David said, that most of the things actually happens on DC side just because it's just so many small things. It's very hard until unless team is very expert to detect those things. So if you can use data and you are able to understand those anomalies and fluctuation better, and of course, running some algorithm, you are able to detect bad guys or bad signals much earlier. And as a result, you can go and take action. Like, for example, just very simple, ground faults. I think those who have dealt with ground faults, they will know that how bad they are. Really, really, really bad, because we just don't know when they occur. And when they occur and frequency increases, it can lead to anything from fire, which is really big, to shutdown, to disconnect, to burning of certain things. And if you have data, you're able to detect those frequencies much before. You're really preventing a big downtime. That's it, as simple as that. So I feel from data point of view, what other folks have said here, we need to be cognizant that, okay, when you're deploying those assets, they are built well. You need to check it well. And I really liked Tim, what he said, that he separated those commissioning guys so that there's no mixing. There's an independent valuation, because ultimately those assets goes to a head of O&M team. And I've never seen an O&M team appreciating EPC team. To be honest, I've never heard a single team. Maybe Tim's team is different. Never heard. They will always say, damn those guys, they built something because they wanted to sell something. And now it's on my head, asset managers O&M, that I have to get my performance up, right? So I think you have to do the designing well, and then yeah, you have to take care of them, take care of these small fluctuation before it can go in and start damaging equipments. So supply chain issue, good luck finding those equipments. At the same time, it can be danger because of fire, So yeah, this is how it works. Little bit of technology on our side, Matthew. Smart Helio, it's very simple. We analyze current and voltages. We understand the pattern. It's coming from my background also. I'm a climate scientist. I studied physics a lot. So I love time series data, and this is where we try to understand that if there's a fluctuation between those data points, can I detect certain problem? We did this experiments for last 10 years. We have a lot of data. I think right now we have data of around 30,000 plants, small and big. Biggest is like 350 megawatts. And we are just collecting those data and learning from that. What has happened before I stop? Two things happen. Of course, the ground team have much more clarity and transparency what to do. The owners have much better transparency that what's going on the field. That's important. And the third thing is, which is most important, that a lot of my customer come to me and tell me, Govinda, great, you have a lot of data. Tell me like which inverters, which POS system, which connector, which panel is better for me for this place. And I think this kind of intelligence is very important for people. And definitely all the high quality guys just come out strongly on our data points. They are highly ranked. So I feel it's also important for people to learn from data point what to deploy as moving forward.
Yeah, I mean, Govinda, you just mentioned that people are coming to you and asking you now, at the procurement stage. Does those kind of people, does that include, say, independent technical advisors for whether it's financiers, backers? Are you starting to have those conversations? What does that look like now? Can you tell me a bit more just about that procurement stage, the questions you're being asked?
I think funders are asking those questions.
Yeah.
Procurement guys are I won't say the procurement guys are asking a lot to us at least, but funders. They are worried about their investments, and they want to know that, okay, these guys have given me this proposal, Govinda, what do you think about it? Does it make sense for my money to be there?
Right, okay, that makes sense to me. So you actually see then in the future a position where you're going to be able to help inform, I guess, these kind of funder decisions.
Absolutely, yeah.
Okay, Brian. Well, listen, that's very interesting on the AI subject. I would like to bring Jörg Althaus from CEA back at this point, because if people will remember from the top of the program, we talked about different kinds of failure modes. Jörg, nice to see you again. Let me just pull up here. I think we talked about previously issues around soldering. Now, obviously, people are taking different approaches to detecting these in junction boxes. I wonder if you can maybe give me a bit of clarity, though. Is AI enough here, or are there kind of different approaches? We can't just rely on AI, I assume. How do we fully address these quality issues and find out what's happening for the things that machine learning at this stage still might miss?
Yeah, sure. I mean, first of all, let's understand if we just take an example of a 100 megawatt power plant and you have your 600 watt modules or something. Now you have 3 junction boxes and you have multiple connections in that junction box. So to sum it up, you probably look at about 2 million solder joints in that field. And now the problem with the issue I was showing is that not every junction box has a bad soldering joint, but even with failure rates of 0.1% or something, you may have 2,000 modules in that system with a potential risk for a thermal event. On the other hand, if you only have a failure rate of 0.1% in the factory, it's extremely hard to detect, because the only way you can detect something that has a low failure rate is by doing 100% inspection. Now, what can you do 100% is you do, and the factories do that, they use AI-powered cameras to look at the solder joint with an industrial camera and analyze the image. That is all good. And is it sufficient? Obviously not, because we still see the failures, because what does the camera do? It looks at the solder joint and sees, is there enough solder distributed, and is the thing in the right position? But what if the solder connection is looking good, but it's not stable over time? There's air enclosures or not enough pressure. Then that solder joint may become loose over time. So even in your pre-shipment inspection, before the module gets tested, you will not detect it, The only way to detect it would be if you do a long-term testing, which obviously is not feasible. So the key here lays in detection, early detection in the field, and finding those diodes that may cause an issue, or those solder joints that cause an issue early on before they start developing in something more dramatic. We heard about drone IR. That's one thing, but again, I think I'm not sure it's clear, but one of the failures, if the diode is not connected at all, you will not see on an IR drone. So you will only see it if you look for lost bypass diodes, and that is a methodology where you systematically go through the strings, measure if you have current flow through the diodes, yes or no, and then find the bad guys. I think when we heard DC 1,500, 2,000 volt systems in the future, 16 amps, the DC side is the most dangerous, and that's where, as we heard, most of the issues lay. So we have to inspect and re-inspect. That's my advice.
Yeah, I mean, inspect and re-inspect sounds like pretty solid advice, which I'm sure I don't really think anyone on the panel would disagree with. And Andrea, if I could bring you back here, inspect and re-inspect, and obviously DC health being increasingly critical as we go forward as well. We've actually, I believe, had a question in the chat about this issue of cross-mating, and I'm wondering if you could maybe give us some clarification on that as well. We're talking about manufacturing projects, and people might have different orders, or people are under pressure, different decisions might get made at different parts of construction. What are the implications for that at the moment, just in terms of quality? But I'm also wondering if you could clear up for me, does that also have any effect on things like warranty, insurance, anything that worth considering here?
Right. Yes, Matthew. In reality, clearly, cross connections is not allowed by the regulations. So as a first comment, so that's really something that is not only not a best practice, but it's also not technically viable in theory. In practice, that is happening for different reasons, but probably one of the main one is really the fact that the supply chain is complex, and having a consistent solution which is intact and maintained along the value chain is complicated, in a sense that also risks to make the supply lower or not efficient. So we are clearly tackling that from different angles. But warranty is clearly one of the aspects. Another one that I can mention about before warranty is the fact that even the standards today help us. Even the 61730, for instance, for PV modules, help us to identify what connectors are plugged on the PV modules. So we are really implementing in the industry tools that help the operators to identify and to gain awareness, as I was mentioning earlier, in the first place, also to help them to maintain intact quality along the value chain. In terms of warranty, I just want to make an example, because clearly there is certain components which are so aware, and certain suppliers that are so aware of the importance of not making cross connections that, for instance, supply the counterparts, as we call them, so the cable connectors. So I'm referring to inverter makers, for instance, in this case, string inverter makers in particular, where when an installer or an EPC buys the box or the product, they find into the same supply the connectors that make them that they should plug to the cable that is the DC input to the inverter. So, and they specify, many of them even directly in the warranty terms, that the warranty is not valid if other connectors are used. So that's, I think, a clear example, a best practice, and an example how the industry really, we should help each other in the industry to really improve the quality and to increase the awareness of this important aspect, because keeping ignoring this or not having the knowledge and the understanding of the potential impact of making these cross connections just leads to potential failures and losses ultimately along the value chain. So it's really paramount.
Yeah, absolutely. I hope that answers that question as well for our viewer. Josep, if I could bring you back here, I think I might have even saw your eyebrows go up when Jörg from CEA mentioned higher voltage systems. Now, I believe actually Shows Technologies won a PV Magazine award at one point for its assembly. And of course, this transition to higher voltage system architectures is coming. There are arguments, I suppose, in terms of performance and costs, and why going to this kind of architecture might make sense. I think it's more of a trend in the US than Europe at the moment. You'd be better positioned than me to say. What I'm interested in, though, is from that EPC perspective, if I've been, and we've heard about how having processes, good supply chains, long number of years working the same way, if I'm going down this new route, prefabricated, EBOS, changing, what does that look like when I deal with a company like Shoals? How can I know that the guys in the field are going to adapt to this new way? What kind of things do you offer here?
Well, I mean, the first thing I like to say is that prevention is better than cure. That's the first thing, right? So we're talking about here about issues that we find on the field as an afterthought, right? So what I've been advocating and Shoals is advocating from the beginning is that we just discuss architecture right from the beginning, and we have the right solution for each project by taking everything into a factory and controlling every single aspect and letting that be in check. For example, in our quality process, we inject more than 5,000 volts in every single solution that we provide, and we test everything before it goes out. That's preventing any potential issues you're finding, and David was referring to. And when it comes to like working with us from the beginning as an EPC, if you haven't used our solutions, what we do is we help you. We have a team of engineers in place that will just study your design. We'll give you feedback on how best to optimize it, not from an electrical standpoint only, but also our solutions can impact civil works as well, because we have solutions that allow you just to go above ground and not having to trench, and that's a very dramatic change of the solution. And we just help them on each stage of the process when it comes to the quote, so they understand where they need to deduct, because in most cases our EPCs don't understand they will lose, they will have to use less people and they don't need to be qualified. Okay. And when it comes to just going and executing a project with Shoals, we have a golden row program in place that we, a very talented team of individuals from Shoals will come to your project and we'll just show you how to do. And our solutions in the end, it's just a mechanical connection. Let's remember that you don't need to do any electrical work on site. Everything is done in the factory. And I was talking to a customer yesterday, and talking about connectors and issues they have found. It's not the same to do a connector connection in Angola or Honduras at different temperatures than doing in a factory control environment. The tool changes and the way you do things are completely different. So you have an effect in everything you do, because you're just basically bulletproofing that for the life of the project. And we also offer 5-year warranty for all our solutions. So if something happens, it's not EPC, it's us that we take it.
Right, well, there we go. You heard it there. I'm sure it's going to take that one. We're getting close to the end of our time, but I would like to maybe just go around the houses here a bit briefer. David, can I bring you back? I'm really kind of conscious, as a way to sort of round out this discussion, you've talked about kind of both that big delta between high quality EPCs and low quality EPCs. If I can put you on the spot, Smart Helio from Helio Volta is all about process, is my understanding of it. What's the takeaway message that people need to take in terms of an EPC? If I want to have a project that's getting financed, what are the core elements of that you find when you're obviously dealing with all of the different clients that you have under management?
Yeah. For, from the financing point of view on kind of reducing risks, again, I go back to, being able to have a, first, as I mentioned, like having a third party QA/QC as part of the, program, it adds already a layer of security, but also getting deeper into the technical evaluation of the programs that the company has developed internally with regards to quality. So these are, quality standards, process procedures, training programs, etc. It's all about like consistency and repeatability and getting the teams trained in new technologies. And again, this is an ongoing, never-ending process, because there's new technologies every day. on these teams needs to be trained as much as possible, as well as keeping documentation, etc. I don't know if that answers your question, but I'll have before I jump off here, I'll make a comment about Team. When Team said that they never had a connector issue in their history, they have to be a unicorn. I've never seen a company that hasn't had a connector issue in their life. So just amazed by that. So good job, Team.
Listen, I'm going to let Tim come
back on that. I would also recommend, if anyone wants to see more connector content, check out David's LinkedIn. There's some really interesting content on there. But Tim, what do you say to that? I mean, I don't know if that's a compliment or a question, but you must feel happy.
Yeah. So, sorry. What I did say is that in the last 3 years we haven't. So everything that we've deployed in the last 3 years, we've not had a connector issue or a DC fault across those. Whereas actually, if I go back to what we were deploying 2014, 2015, 2016, 2017, at the height of the solar boom in the UK, yes, my life we had connector issues, and actually it's that everything that you've all put on the screen. We've got data packs that show that, but we've learnt from that. And actually, I asked just on the connector piece, I actually asked our head of assets, our asset director, this question. I said, why is it that we haven't had those faults in the last 2-3 years? And he said, it's really easy. It's 4 things. 1, quality subcontractors, and our subcontractors know what they're doing and work through with what they're doing. 2, this has been mentioned already, compatibility between connectors, and actually having connectors that are compatible. And back in the day when we were absolutely flying and building things in 8 weeks, we use whatever connectors we could get off the shelves as everybody else did. Now we really don't, and that compatibility is key. Thirdly, we build in mud and rain in the UK, and in the Northern Territory in Australia, we build in dust. Quite severe dust, and actually having crews that realize that they can't just connect connectors if they're not in a condition to be connected, if they've been sat in water, if they've been, what is the condition of that connector before you chuck it together. And I think for me, it's those really simple steps, and knowing the effect that actually simple processes have on what we put together is key to having quality projects, and having the same people and the same processes and the same teams that do that project after project. Our challenge is always scaling up like everybody else, but actually we've hit that challenge head on in terms of, it's really dull stuff. It's processes. It's making sure that your systems are in place. It's making sure that your supply chain is correct, and making sure that your engineering team is learning from everything that goes before them and feeding that back down to what we're building now.
Brilliant. Thank you very much, Tim. I do have to come to an end. I am reluctant to end without just having one more word from Govinda, just purely because, Govinda, you're the AI forecasting man now. You're looking at faults in the future. If I can just get you to close it out with a little prediction here, we'll do an event next year, I'm sure. What are the stuff that you're forecasting and looking at to the future? What's the quality issue that you think might be something that we need to really be picking up on moving forward?
I think, apart from the DC connections and all this thing we need to do, I think inverter failures. Yeah. I think what I feel that people are very worried about inverters because of supply chain issues. Mm-hmm. Before it was very available, but not now. It's not. Oh. People are very, and definitely we need to work on our BOS and connectors. That's
for sure. I think that's a great thing to end on. If I try and start a conversation on inverter failures with 1 minute to go, we're in deep trouble. Well, listen, thank you all of you for joining. I'm now going to wish everyone in the audience well, but it's been a great panel and a thoroughly enjoyable one, I must say, as well. Now, just one more time in a more formal way, thanks very much again to all of our panelists, including our platinum partner, Shoals Technologies, and to our gold sponsor, Intertech CEA and Stoibli as well. And of course, PV Magazine Week Europe has other sponsors too, lead partner Create, platinum partners Hwasun, Jinko Solar and Trina Solar, and gold sponsor Belectric. And you can catch up with some of what they have to say in other sessions that are happening in PV Magazine Week Europe this week. So tomorrow, things start again at 11 a.m. CET. We will be exploring next steps for PV technology. Now that's, we had some module, that's going to be big on modules, cell and module technology, TOPCon and beyond. And then we're going to be following that up in the afternoon, I believe, with a quality session as well, which will, I think, possibly appear, but followed by more quality, including UV-induced degradation. We will have module quality and risk, ensuring reliability in a rapidly expanding market. That session starts at 3 p.m. So make sure you check that out as well. And then on Thursday, it's all about battery energy storage. I believe there's a session at 11 a.m. till 12:30 on what to consider when purchasing BESS for projects in Europe. And then at 3 till 4:30, we'll have renewables and BESS co-location in Europe best practices. So just to sum that up, tomorrow, big module day, make sure you sign up and get along. And then the following day, it's all about that super exciting subject, battery energy storage. So once more, thank you very much to all of our participants today, fantastic expert guests. Thank you to our audience for attending, and of course, our PV Magazine Week Europe partners. Goodbye.